Man-in-the-middle attacks are very important network kind of attacks. And before going further, we need to start with the basics. And it's with the OSI layers. We have 7 layers corresponding to application, presentation, session, transport network, data link, and physical. You can use the sentence, all people seem to need data processing, to memorize this layout in a better way. The most important protocol we will discuss in this video is called the ARP protocol, which actually functions at the data link 2, and it is responsible to translate the IP addresses from layer 3 to MAC addresses. The example we'll be giving under the man-in-the-middle attacks is the ARP spoofing, or you can call it as well ARP cache poisoning or ARP poisoning. It has various naming. So actually, this is a technique by which the attacker sends spoofed ARP messages to a LAN. Generally, the aim of this attack is to associate the attacker's MAC address with the IP of another host, such as the default gateway in most of the cases, causing the traffic to be sent to this IP address rather than the legitimate IP address. So, in the normal situation, if I am here, Mr. Nice, trying to communicate with the default gateway of the IP 192.168.1.1, I don't have the MAC address of the default gateway. So as you can see, the message propagates from the application layer to the physical layer, and it needs to be translated at a certain point of time from the IP address in the packets to the MAC addresses in the frames. So the computer will need to know the destination MAC address at a certain point of time before sending the data. From the top-down approach, the computer will send the messages to the default gateway of this IP that mentioned earlier. So in order to know the next step, which is the MAC address, the computer sends an ARP request on the network asking all the hosts on the network who has the IP address of .1.1. So the computer concerned will reply by its MAC address, and this reply is cached on the Mr. Nice machine. This is the situation under normal circumstances. So in not normal or abnormal circumstances, Mr. Bad, who is the malicious user here, will have access to the network. It's very important to have access to the network because this attack only works this way. He will have access to the network, and he will send ARP replies saying that his MAC address is associated to the IP .1.1, and as well saying that his MAC address is associated with the IP .1.2. So as you can see, there is no request for ARP, but Mr. Bad was able to send the reply. This is a vulnerability in the ARP protocol. You don't need to have, or you don't need to be authenticated in order to send a reply. So any host can just plug into the network and just send a reply to all the hosts on the network. So in this case, Mr. Nice will cache this request. Will cache this message that the IP.1.1 is associated with the MAC address that ends with 98-58. So as you can see, on the next attempt to send the data to the default gateway, the data will be redirected to the computer of Mr. Bad. And actually, this attack is used as an opening for other attacks, such as denial of service, man-in-the-middle attacks, session hijacking attacks. You can change the data, you can monitor the data. It can be active, it can be passive kind of an attack. As we said, the ARP protocol is the de facto protocol nowadays, communication, and it has this vulnerability. It's a stateless protocol where actually the network hosts will automatically cache any replies, as we said. So they will cache any replies that they receive, regardless whether the network host requested them or not. Even if the entries in the cache that are not expired, they can be overwritten when a new ARP reply packet is received. As you can see, anyone having access to the network can take advantage of this vulnerability and just route the traffic to his machine. This kind of attack actually has some legitimate uses in some cases. For example, especially in server failover cases, some server can take on the traffic of another server in case of a failure, but this is not well used because it needs dedicated tools to be employed. In this video, we'll see how to do actually ARP poisoning attack. You go to the Windows machine, which is the victim's machine, and type ipconfig to see that the default gateway of this machine is 211.2. In order to get the MAC address of this default gateway, just type the command arp-a and you'll see the cached entries on this machine. The first entry is the default gateway and the MAC address ends with D2. So our attack will actually change this entry from D2 to a different MAC address, which is called ARP poisoning. We go to the Kali machine and open a terminal. Write ifconfig to get the MAC address of this machine, which is a malicious machine that will have access to the network, the illegal access of the network, and will send fake ARP replies. So as you see, the MAC address ends with 4B. A good tool to do this ARP poisoning attack is called EtherCap. It's under sniffing and spoofing. You open the application, press on the sniff menu, and press on Unified Sniffing, and select the interface. Then you go to the hosts and press on scan for hosts. So now this is scanning the hosts on the subnet that it actually resides on. As you can see that 4 hosts have been added to the host list. If you want to see the host list, just press on the host again and host list menu. As you can see, it identified 4 hosts. The IP address of our target machine is 129. So you select 129 and press add to target 1. So 129 now is our target. Next is to execute the attack. You go to the MITM man in the middle menu and select ARP poisoning. Then take the option only poison one way and select OK. So now actually a fake ARP reply has been sent to our target machine. How to verify this? You go to the victim's machine again and then you type the arp-a. Notice here the current cached entry is D2 for our default gateway. So now the entry changed to 4B, which is the MAC address of the malicious machine. So all the requests that are going to the gateway will now be diverted to go to the victims or to the criminals or malicious users machine. If you want to verify this, you go to Kali again and you fire Wireshark. Then you start sniffing. Then you go here to the client's machine, the victim's machine, and just open web browser and just go to the Google page. And if you go here again, you'll see that the communication has been established and the traffic is being redirected from 129 to our machine. If you want to filter here, just ip.source equal 129. And this is all the traffic that's coming from the victim's machine. If you want to verify real time, just open this again, minimize it, okay, and just open another website and you see the traffic being captured real time.